been after me to do this for quite a while actually. But what I'm going to do is a wall-sized radiator using heat-resistive ink. So what we need apart from the heat-resistive ink is some copper tape, and that will form your contacts. Some masking tape to make whatever pretty design that you want. I'm going to use a ladder design as it happens. Although you could do solid blocks or you could do an image if you wanted, I'm going to do a ladder because it's actually more efficient at the heat distribution. So I'm going to use a tape to mask off a ladder design. A roller to paint on the ink. And the last thing you need is this. This is your heat controller. Now, this one I got from a local electrician's store, and it's meant for underfloor heating mats. So it's a digital controller and it's quite expensive. This one's actually £60. But you can use any heat controller that will do the job, and there's an awful lot of them out there. So you don't need to go quite as high end as this. And inside the box, you've got the actual controller unit with its connections, which I'll show you later in a bit more close up. And then the important bit is this bit here. This bit is actually the thermocouple. And the thermocouple is the bit that controls the electricity going to the heater, depending on how hot the heater gets. And obviously, you set your controller to the temperature you want. Now, when it comes to placing the thermocouple, what you have to do is place it somewhere in the middle of your heating area, so that it picks up the average heat. Now I'm obviously going to place mine round about here. I've prepared this before. All it is a sheet of drywall, rock wall, plasterboard, whatever you want to call it. It's a sheet of 1.2 metre by 2.4 metre drywall, screwed flat to the wall to make a representation of the wall. You could actually just paint it straight on the brick if you want. You can paint it on wood if you want, or you can paint it on plasterboard like I'm about to do. And right next to the plasterboard, here, I put a little box on the wall because my thermocouple is going to come out from where I place it into the box, so the feed wire will go into the box, and then the control unit will screw onto the box. So the first thing to do is to decide where you're going to put the thermocouple. Now I'm obviously doing this as a prepared piece for you, so I've got here this bit of wall. In order to get this thermocouple into the centre, what I have to do is drill a hole and drill another hole and put something in there that's quite stiff but bendy, so I can attach the wire to it and pull it through to my box. Now you can buy bits and pieces like this, and they're called pullers. Electricians have them for pulling various cables through. When you look at the thermocouple, there'll be a tiny bulb at the end of it that's covered in rubber. That's the sensor element. The rest is just the wire. So what we want to do is leave the sensor sticking here and the wire here. So you attach this to your puller and just pull it through. Thermocouple in place. This will then be cut off and put into there. Now I'm doing this on the surface of the wall so that you can actually see it and see all the machinations and bits and pieces and how you do it. But there's no reason to do it on the surface particularly. You could actually do it behind the wall so that you've got the drywall heated from behind, in which case you do all of this setup before you put your unit on there. If you want to convert an existing unit, you obviously have to feed the cables to it. If you're not confident about feeding those cables, then get an electrician to feed them for you. Anyway, once we've got that in place, then we're going to put it just below the surface of the board. Because we want a nice flat surface, we want to put it just below. You don't need to put it just below. You can put it anywhere you like. If you don't mind it showing, you can put it anywhere. But I'm going to put it just below. So once I've positioned it, what I need to do is plaster over it. So I'm just doing a little bit of adjustment there to make sure that that goes in nicely and stays in place. So that it will be just below the surface. Then once I've got it in position like that, I need a little bit of filler. and leave it to dry. Now because that's quite deep, when that dries it will sink in a little bit. So we refill it and then give it a light sand. When I've done that, I'll get back to you. So here's the thermocouple, the sensor, and it's just below the surface. You can see a tiny bit of filler and then a slight black mark where the actual sensor is. Now this sensor will sit just by this particular part of the wall heater, and you need to be careful obviously when you sand that, if you sand it smooth, not to sand your sensor down. It's literally just below the surface, which is where you want it. Now what I've done here is obviously add the copper tapes. These copper tapes, incidentally, are 5 meters long. They're 5 meters long by 1 centimeter wide. And when you apply them, you need to apply them as one continuous strip. Now this is 2.4 meters, so I get a bit left over about that big. Don't be tempted to reuse that, you'll be very sorry. Make sure that you do a one continuous strip, it makes everything work that much better. And the way you do it is just mark out the place that you want them to go. Now these sections should be around about 400 to 600 millimeters. Don't go bigger than 600. Because I'm doing 1.2 meters across and I'm using little gaps to make it all nice and neat. I'm making these 500 millimeters across. So they're 50 centimeters across. And I've marked a line down where that 50 centimeters will be. And all you do is line up your tail and pull off the backing material. And then smooth it down. Now when you smooth it down, you'll see little wrinkles forming, and you rub those wrinkles out with a cloth, with your hand, with the back of your finger, anything like that is actually going to do that job. And continue down until you get to tape all the way down the board. Now, you need to leave a section of tape about 50 millimeters, 2 inches, 5 centimeters long at the bottom to make connections to it. When we come to making connections, we'll do a close-up of that so you can see the length of tape and see how to connect that tape up. You'll also notice that at the box section here, what I've done is feed the thermocouple wire through. So the thermocouple wire goes through the box. Then I've also got this grey wire. This grey wire is 2.5 millimeter twin-core earth. It's the standard power supply cable for the UK. All UK ring circuits are made out of this. Now that will differ depending on which country you come from, but you need to supply it with cable that's going to take what a normal plug socket would take. So this will actually take 13 amps, no problem at all, and that's what it's rated for. Actually it's rated much higher because it's for ring cables. And I've taken the cable from the box and behind this panel here, just dropped it down around the wall and it drops on the floor there. Again, you'll see that connection later. And that's the main connection of the heater unit to the control box that we're going to fit later. Now all I have to do is finish putting on these copper tapes and then put on the masking tape to form the pattern that I want to paint. So I'm going to do that and then get back to you. So there it is, all nicely laid out with its copper at 500 millimeters, my main element. So we're having a look at the bottom of this now, and as you can see, this is the gap between the wall and the floor. Now all walls and floors have gaps. If they don't, you're going to have to cut one. But there's the gap, and here's the cable that I dropped out from the control box, which was this grey cable. When you cut into that grey cable and peel it back, what you get are 3 wires. You get a blue, a brown, and a wire with no insulation. The brown in the UK is the live wire, the blue in the UK is the neutral wire, and this one without any insulation is the earth. Now it's going to change depending on where you're from, so you'll have to check the code. Like I say, if you're not comfortable with this, you should be getting an electrician to do it. But if you are comfortable with it, it's fairly simple, it's colour to colour. Now what we've got here is our strip that we put up the side coming down to the bottom. Here's the last piece of masking tape. The first heater bar will be here and there'll be no heater bar here. So what we need to do is make a good firm connection to that. Now how we're going to do that is clamp it down. So I've got here a small clamp and I've folded back that copper and laid it over one over the other to make actually quite a thick copper connection. Now I put a clamp plate on that, and that should clamp everything down rather nicely, but it's also going to allow me to attach my wire on there. So I'll wind the wire round and screw everything down, and that's what we're going to do now.
Now I've made sure that behind this is a piece of wood, so that when I screw into that, it's going to screw into the wood. And there we go. That's our electrical connection, and that will cover over when we put the skirting board on. And I'm going to do that to the other two now. The other two are neutrals, because I've connected both up to the live. The two edge plates I'll be connecting to the neutral, so this blue wire will go to one of them, and I'll do a connecting wire between the both of those to make the neutral connection. So after we've done everything and neatened it all up, there are the connections. That's the far one. So there isn't actually an earth with this. All you do is wind up the earth, cover it with earth sheath, which is this stuff here, and fix it down somewhere firmly, because there is actually no earth with this appliance.
Okay, so there was a very good reason that we did those connections first. We did those connections first because we're going to need to be able to measure resistance. Now the amount of power that this thing will pull is equal to the amount of as directly related to the amount of resistance that it has once you've painted it. If you get a resistance around about 10 ohms or so, it's going to pull about 15 kilowatts, and it's going to give you a huge amount of amperage, like 23 amps or something like that. It's enormous. You're aiming sort of 50 to 100 ohms is what you want. When you get to about there, it's going to pull about a kilowatt or so, and about 5 or 6 amps when it's turned on. So that's what you're aiming for. Now obviously, in order to do that, you need to be able to measure the resistance. So we've wired the thing up now, and the other end comes out here to really strip that back. Then we can expose our live and neutral, and we can take our resistance reading from there. Now it's likely to need 2 or 3 codes. And again, it's going to be dependent on local conditions, like what you put it on. Now, it's like any paint job. If you put it on a poor surface, you're going to get a poor job. You need a good grounding for it. The surface should be flake-free, that kind of thing. Just like when you're painting anything else. Paint on a bad surface, you get a bad job. Painting a good surface, you get a good job. If the surface is very absorbent, it's obviously going to suck quite a lot in there into that, so the paint actually seals it. So you might want to seal it first with some kind of sealer before you paint on it. So just bear in mind the general stuff that you do whenever you paint something, because all we're actually going to do now is paint it. Once we've finished putting the masking tape on and giving it a bit of a rub over to make sure that the masking tape is nicely stuck down, the tape won't bleed behind it, we're actually ready to paint. So you take your heat assessment, give it a bit of a shake, open it and pour some in. I'm applying it with a roller, but you can apply it with a brush or just about a spray gun, any of the method that you want. And you literally roller it on, making sure to cover the copper. Once you've rolled it on, give it a couple of hours to dry. Test the resistance. If you're in the region of 100 ohms, you're going to be alright. If not, give it another coat, wait for it to dry, test the resistance. And when you've got a resistance that you're happy with, around about 100 ohms or so, leave it for at least 12 hours, test the resistance again, and then you're ready to connect it up to the mains. Anyway, I'm just going to paint the rest of this and then get back. So here it is all finished and with the masking tape removed. Now, I think this lab-like configuration actually has a better overall performance in terms of evenness of heating. You don't have to do it like this, you can just do a block colour that makes it much thicker, and it will heat just slightly hotter at the bottom and slightly colder at the top. Now I used about 25 millilitres of ink to do this, and there was a slight problem in that the ink is actually so conductive. In fact, after it had dried out, I washed it off because it was just too conductive. Because remember, you have to aim for a particular ohmic value in order to get a relatively even voltage drop across it, so that when you put your voltage through it, then you get the heating effect that you want without drawing too much in the way of power. Now this is around 65 ohms for this structure, which is pretty phenomenal. And that means it's going to draw about 3.5 amps, and it's going to give out about 0.8 of a kilowatt in terms of power. So that's what that particular structure will do, and I'm quite pleased with it at this stage. Now, obviously, the kind of amps and power it'll draw will depend on your voltage of your country. So the US is 110, it's going to change the calculation and change the kind of power that it'll do. This is specific for the UK, which runs at 230. You can calculate that really, really easily. You can use the DC calculators. They give you a guide onto what it'll actually perform because, of course, we all use AC current. AC is slightly different. And the DC current uses resistance, AC current uses impedance, and impedance can be guesstimated using DC resistance. They're just guides, guys. Don't write back to me telling me all about this. They're just guides to help you, so it'll get you roundabout figures. Now, all we're going to do now, obviously, is wire the thing in. So let's have a closer look at a couple of controllers and the controller we're going to use.
So in terms of controllers for this thing, you've actually got quite a large selection, ranging from this thing, which is a rheostat potentiometer controlled pulse width modulator for a small power circuit, usually for something like a toaster. You buy them as a board actually, and they just have a connection point for your wires directly from your mains, your live and your neutral. You wouldn't put it directly into the mains, you'd actually put it into a plug so that you've got a way of moving it around, plugging it in and out, so you've got protection from the fuse that comes with the plug, and you can switch it off because normally plugs are switched. So those are really, really cheap boards, kind of in the order of £1 or two. If you want to take a step up from that, then you've got this kind of thing. This is a PID controller. Again, it comes as a kit, and it comes as a kit of 3 parts. You have this, which is silicon controlled rectifier for high voltage, and this, which is your thermocouple or your sensor. Now you put this in the same place that we put the other sensor, it's exactly the same thing, and it wires into the controller, the back of the controller, and the controller gets wired into this, and this basically sends a signal to this to turn it off and on, which is how you can control the electricity. So you can use a little PID kit, if you like, and that was about £20. Now, because I'm doing kind of a wall demonstration and we're thinking about something for the home, that's what I went for. Now, the benefit of this thing is it's astonishingly simple. If you look at the back of it, then it gives you all the directions that you need to know. So there's a whole load of little pins at the back here, and they're painted and labelled up. So your supply goes in there, your load goes in there, so an X by that to tell you put nothing into it, and that's where your thermocouple goes in there. So you literally take those wires, slot them in and tighten them down, and you're done. So that was actually quite expensive. That's about £60 for that particular thing, and the only reason I went for it because it looks pretty, it's dirt simple to do, and anybody who wants to do something like this, well, just go for one of these and wire it in according to the instruction booklet that it comes with. Anyway, that's the kind of variety that's available to you for controllers of this thing. So here it is wired in exactly how it says. There's a neutral there from the supply, a live from the supply. The earth has been connected to this earth with the crimp. These are count as permanent connections. Then we've got our unit, which is these two slightly thicker wires, neutral connected where it should, live connected where it should. And then it says sensor here, which is our thermocouple. And it's so helpful, it tells you black and white. And there's the sensor that has been trimmed off. Then you just pop them into the little holes and screw it down. And just make sure it's firmly attached. Fold the whole lot up and put it in place. Now, a word to the wise. I actually bothered to take my electrician's qualification years ago because I knew that this would be something that I would want to do, so I bothered to do it. Now, in the United Kingdom, you're not allowed to do anything to house electrics unless you are a qualified electrician. Now, this particular thing has been done via a plug, and it's going to go into the socket right next to the unit that you can see. What that means is it qualifies as an appliance, a homemade appliance. So you're sort of sidestepping the regulations there. However, you should not be doing this unless you're comfortable with electrics. If you're not comfortable with house electrics, don't attempt it. Now, that's a warning of safety for you and ass covering for me. If you do this and blow up your electrics and come looking for somebody to blame, don't blame me, I've warned you. Don't do it if you aren't confident and competent at doing it. If you do it of your own volition, then this has been a demonstration for educational purposes only. Anyway, let's move on. Okay, there it is, all connected up, closed up and ready to go. Incidentally, here's a fine example of the kind of thing you think about when you're used to doing this stuff that you often forget to mention because it's just second nature. If you remember, this cable actually just goes straight into the box. Now, it's got a plug on the end of it. So, of course, somebody could come along and tug that cable. If that tugged that cable hard enough, they'll pull out the connection. So you put a safety clip on. Now they'll tug against the safety clip and not against the cable. That kind of thing is the kind of thing you think about all of the time when you're used to doing something. But it's really important to do stupid things like that, which is why it's important to be familiar with this kind of work. But there we go, it's all connected up and ready to run. So there it is, ready to trial it. Now, I've changed camera so you can see the full length of it, so it's a bit echoey because that is the only source of heating I've got in my lab, and it's a bit cold in here, but I plan actually on heating the entire lab with that radiator. It's all set up and ready to go, so let's turn it on. And that's 18 degrees. So that is now heating up to 18 degrees. I don't have an infrared camera, which is kind of a shame, really, because it'd be great to see an infrared picture of it. But if we use a temperature monitor, the bars are getting to about 22 degrees, and the thermocouple, where I put the thermocouple in the middle there, is at 18 degrees, which is what you'd expect. Now, it's an interesting little aside, because a lot of people think that I don't have a safety-conscious view. When I set this up, right off camera, what I've got here is a fire extinguisher, because I don't know what's going to happen here. I just turned it on and hoped for the best, fingers crossed. So I made sure I was ready in case anything dangerous did happen. I've got the equipment to take care of that. But anyway, it hasn't, and there we go, it's all nicely finished. Now, that is obviously live, so you can't touch that. And in the UK, we're required to cover all of this stuff up. So what I'm going to have to do is put some kind of covering on there. Now, the device that I got to control it's pretty cool, actually. It allows you to set the various kind of coverings, and it also is an energy monitor. So I'm going to monitor that energy usage over the next few days and probably do a report back on its energy usage. I plan on covering that with some vinyl. Now, you can cover that with anything. I mean, although we've put that on the wall, that would go on the floor quite as well, or in the ceiling if you wanted to. On the floor, you would cover with tiles, carpet, wood, vinyl, laminate, anything you wanted. On the wall, equally, you'd cover it with those kind of things. So that would go into a bathroom, no problem at all, because you just put the tiles straight on top of it, and you would tile on top of it. As I say, I'm going to put a vinyl on it. If you wanted to make an area that you could see that was a radiator, well then a piece of plastic screwed over the top of it would be just fine. The most this ever gets up to is about 40 degrees centigrade, so it's never going to go higher than that. So you don't have any worries about burning and melting things, because it just doesn't get hot enough. Your cup of tea is much hotter than that. Anyway, there we go. It's actually pretty warm. When I came in earlier, I was wearing 2 coats because I'm cold. Now you can see I'm in my usual blue short sleeve shirt. Feeling pretty comfortable, actually. So I'm very pleased with that. And I shall just cover it up and cap that bottom area off that we see with a bit of skirting board. And there we go. So there you go. 1 coat, 25 millilitres of this heat resistive ink was enough to make that massive radiator. Now, I only painted that one as an example, and you could quite happily paint the whole way around your walls if you wanted to, and your floor, and have ambient heating. That particular one there heats up quite nicely and only takes about 3 amps. It's a 0.8 kilowatt heater. Most of these electrical heaters are 2 kilowatts and do an appalling job. That's 0.8 kilowatts and gets the temperature up very quickly and very nicely indeed.
Now, if you're going to do this, you need to be aware that there can be problems that arise. The problems are mostly to do with the way that you do it. If you do it on a bad surface, well, you're going to get a bad job. You need to make sure that everything sticks down. So when you put the copper tape on, the copper tape has to lie flat. When you paint on the copper tape, you have to make sure that you paint on the copper tape, because the junction between the copper and the carbon will form a very hot resistive circuit if the copper isn't stuck down and you don't paint on it properly. So prepare it just like you would any other paint job. You're not going to be able to slap it on really, really quickly and badly and hope for a good job. It just won't work. But then neither would any paint job. You have to do your preparation. Clean your surface, seal the surface, make sure the copper's stuck down, make sure the paint is applied properly, and then you're going to get a good job and years of service life out of this thing without any problem whatsoever. Anyway, I do hope that was of interest to you, and thank you very much for watching.